Thank you, Julie. Hi, everybody. So at last fall at Strata, New York, I said, what talk do you want me to give? And Alistair said, how about a talk on how every visualization you've seen is wrong? There we go. And I said, that sounds like a great talk. And I gave that talk, and that was about a 10-minute talk. And part of what I talked about in that talk is that for visualization to be successful, it's got to have these four things. It's got to have a purpose and focus. It's got to have the right information and only the right information. It must be correctly structured, and it must have useful formatting. And I thought this was a pretty nice little stack. And I say stack because these are actually very intentionally in an order. You have to start with purpose at the bottom. That's the foundation. If you haven't got that, the whole house falls down. Then you have to have the right content. If you haven't got the right content, it doesn't matter what you do with the content, whether whatever structure, whatever formatting you apply to it. It's got to have the right structure to reveal what's interesting, what's going on. And finally, formatting is what I talk about, things like labels, best use of colors to call out things to highlight and whatnot like that. And so I thought this was a pretty good stack and decided to build a new talk, a longer talk around what do I mean by all these things, talk about each more of these in detail, talk about why these dependencies exist, and give some examples of these done well and occasionally done poorly. So the reason that they're in this order is because each subsequent of these four pillars depends on the previous ones. You start with purpose. Why are we here? And the purpose is going to inform the content that you choose for that. Once you have purpose and content, they're going to choose the structure. How do you display it? What axes do you choose? How do you pick the layout? And once you've got those things in place, then you can apply the formatting. And that's, again, going to be informed by what is the purpose, what kind of content do we have, and et cetera. So this hierarchy, this ranking is very important, and because it's important, we're going to keep it on the slides for the rest of the deck. This is the shorthand. Purpose informs content, informs structure, informs formatting. So let's start with purpose here, up in the corner. When it comes to visualization, there's sort of two broad domains that people use visualization for and that we talk about. And people usually talk about this interchangeably. I want to clarify here. So these two domains, the first one is analysis. Mostly what I'm talking about is not analysis. Analysis is when you're not sure what's in the data. This is much more exploratory. You can do certainly analysis where you know exactly what you're looking for, and that's fine. But here what I'm talking about is when you're just kind of getting in and mucking around with the data and just really seeing what's there, and you really don't know what you're going to find. This talk is not so much about that phase. Presentation, when you want to communicate something to somebody else, that's what this talk is about. You have to know what it is you want to communicate. You have to know why you're having that conversation with them. It helps a lot to know who you're communicating with, so we're going to talk quite a bit about that. But keep this in mind. If you're saying, well, I'm just exploring, I don't really know what's there, that's fine. These are not focused on that so much. So for presentation, for creators, you have to understand, why are you creating this visualization? Like there's some reason, even if it's, well, I'm just showing the data that we have. Well, what data are you showing? Who is it for? What do they need to understand? What are you trying to communicate? How will it be consumed? These days, that's a huge question, right? If you're looking at something that's going to be consumed mobily on a phone versus something that's going to be consumed or displayed on a big screen or on a projector like this, those are very different contexts of use. What it is you're going to visualize, the level of detail, the volume of data, the interactivity around it, these are all really different. You have to understand how something is going to be consumed if you want to effectively design it and effectively display it. And then this is from the other side of the coin. As the consumer of a visualization, ask yourself these questions. Why do you think they created this visualization? Is it evident? Who did they create it for? Did they create it for you? Did they create it for somebody else? The visualization that you create for a technician who's fixing your laptop is very different than the documentation or the visualization or the help for someone who's going to use the laptop, right? Similarly, I recently saw a piece of documentation that was talking about best etiquette for online, et cetera, and it said, for executives, please try to limit the use of acronyms and technical jargon. Because the executives may not have all the knowledge and insight that people who are more technical will. And so again, to be successful, to communicate with a given audience, you have to know who they are. So you as the consumer, these are great questions to ask when you're looking at a visualization and say, do I think the person who created this actually had a purpose behind it? Did they know who it was for? And what are they trying to communicate? What's the goal underneath here? So having a purpose gives you a target. It gives you something to point at. It lets you know if you're on the right path. Now, this is tricky, particularly when you deal with teams, because different people have different ideas of what the same words mean. And your idea of the target and their idea of the target can be different. So it's important to communicate about this. That last one there, that's the cloud. Because you got to have a cloud in a talk at Strata. These can vary. These can be different, right? What the target is, what you're trying to do, might evolve over time. That's allowed. It doesn't always have to be the same. Occasionally what you get is moving targets, and those are harder to hit because as the spec changes, what you're going to visualize, what you're trying to communicate is going to change. But, and I'm harping on this purpose thing quite a bit because it really is fundamental. It really is important here. Different destinations require different maps, right? Different purposes are going to require different kinds of visualizations. You have to know where it is you're trying to go before you can create a document to support that. And this applies not just to visualizations, obviously, but to other kinds of technical documentation, to other kinds of software, to other kinds of interface. This is fundamental. And part of the reason that I spend so much time talking about these sort of purpose and context of use and audience issues is I came into visualization through user-centered design. And so if you're a user-centered designer, this is like kindergarten. This is the very basic stuff. Who's your audience? What do they need? How do you design for them to make them successful? And it's so critical. It's so critical. It's so important that you do not think of yourselves probably as content creators if you are technical, if you're developers, whatever. But you are creating anything that anybody else ever is going to look at, or anything that you're going to look at for your own consumption, your own documentation later. You're creating content for another human being to consume, and doing it effectively will make or break the success of that communication, of that interaction. So, to that end. So this is from the Many Eyes website, and there's other obviously resources that do the same thing. There's many different graph types, and they're labeled, right? They're labeled with the different kinds of communication that these graph types specifically enable. So there's examples here. See relationships among data points, track rises and falls over time, see parts of a whole, compare values. These are all different kinds of expressions of the data that's there, and you may be interested in different happenings in the data. You may be looking for different kinds of highlights in the data. The different flavors of exploration that you're going to do, the different things you need to communicate, are going to be informed by the style. So you need to know what it is you're going to communicate before you pick a style of graph. So fundamentally what it comes down to, you must be able to articulate your purpose to be successful. And if you're kind of not sure, what you're doing, like, well, what's this for? Well, it's to show the data. That's like saying, well, what's your business model? Well, we're going to sell a lot. Well, okay, we knew that, but give me a little more detail, right? You need to be a little more articulate than that. You need to have a little more detail, a little more plan to really be successful. So moving on from purpose, let's talk about content. The interesting questions here are what data matters and what relationship matters. Well, how do you know? Well, purpose will tell you. The purpose is going to tell you what's important. You then, when you have the purpose well defined, you can pick what the right data is to include and what the right data is to exclude. That's critical. And the way that this works, and you can measure this, the way that this works is if there's extra points on the page, on the screen, whatever points means to you, lines or bars in your graph, whatever that is, the more targets that there are on the page, the longer it takes to find the one that you're looking for. And if you have all the data on the page, the one little bit that you're looking for takes longer to find. We have this culture, or at least where I come from, there's this culture of, show your work and more data is better. And well, it's nice that you guys have 10 million data points, but we actually have 100 million data points. So clearly ours is superior, right? We know this culture, this exists. And that's all good and well until you actually need to find the piece of data that you want. I forget the quote. Some technologist in the last couple of years is like finding a needle in a haystack is easy, right? The problem is finding a needle in like a box of needles. That's much harder. And when everything looks like a needle, it's hard to find the one you want. When there's only one needle, that's much easier to find. So your goal, if you are creating visualizations, is to make that needle that you're looking for stand out. So here's an example. This is actually came out a couple months ago. My friend Brandon did this. It was very simple. He took the US Census map and the US Census results, and he actually then added Canada and Mexico, which are truncated here a little bit, and he put every person on a map. So at the full size of this that I've cropped a little bit, there's 450 million and change dots on the map. Piece of cake, right? So if the goal of this is find the house that you grew up in, assuming it still exists and that somebody lives there, it's on this map. Go. Tell me when you find yours. It's impossible, right? You're not going to be able to pick out your place within 454 million or whatever it is. And we can add labels to make it easier. Did that help anybody? Not so much. But the beauty of this interface is you can zoom, right? And you can scale this. And so this is where it gets interesting. Before, we sort of saw these black smears because it was too densely related. So here we're looking at the city of Portland. This is the southwest part of Portland. You can see downtown is these very dense apartment buildings, right? These very dense blocks. But when you move out a little bit further, what you're looking at when you're seeing these individual tiny little dots and clumps is you're seeing representations of individual people, individual families. And now that I'm not looking at 450 million dots, it becomes more reasonable to say, hey, that's the house I grew up in. Right there, that little red dot in the lower corner. If we want to include all 450 million points, that's great, but it doesn't help me find the one I'm looking for. If we focus down to a known subset, if we filter, right? We filter down to a region, a frame that we know is relevant, then finding the point that you're actually looking for becomes a lot easier. So this is a super exciting project, by the way. It's very simple. It's just what I've shown. You can zoom in and out, and you can turn on and off the labels, and it's awesome. Because there's everybody in North America right there. So that's most of what I have to say about content. But really, the key then, what it comes down to is include the content that matters, exclude the content that doesn't matter, and you make access to what matters much faster, much easier. Structure. How do we best reveal data and relationships, the important ones? There's whole books about this. There's a lot of theory about this. Choose meaningful layout and axes. Well, of course, you're going to choose something meaningful, and then how do you know what's meaningful, and how do you choose? It's informed, obviously, by purpose, by content. This mantra will get old by the end of the talk, but it's really true, and it matters. So one more borrowed slide from the previous talk. This is a structural fail. We know what the purpose is. It's to compare the results from these different polls. They've got the right data. That's good to go. Those two are successful. But the structure is just not helping anybody here right now. This is not a structure that reveals these small differences. It's also a misuse of this format. But if the structure is to compare these values, it's really hard to compare arc lengths like that. Like, it's just not working. So they started off well, right? The caption for this image that I've cropped out here was something like competing polls or something like that. So they knew that they were trying to compare these poll results. They've got the numbers, the data's right there. You could list this in a table very simply, but the structure does not support what's going on there. And I don't want to say that this is a common problem, but what often happens is people will pick a structure before they've really identified the purpose. Because they want to use this cool donut graph, or we're going to use a network graph, or we're going to, whatever the tool of the day is, or whatever the tool we used last week is, we're going to implement the same structure in that way because it's what we're used to. And instead of really thinking about the purpose, instead of really thinking about the relationships in the data that need to be revealed, people just go with the defaults. And if you've ever seen me give my longer tutorial, defaults are really good. Defaults are really useful and important. And we like defaults because we understand them and your audience understands them and we have good tools. And you should always consider using a default. And defaults are great unless you've got something better. But something better is typically going to be more expensive, right? In terms of you developing it, in terms of teaching your audience how to use it, in terms of the tools for it. So there's a reason that defaults exist. There's a reason we like them. But I say consider them. Don't use them unquestioningly. So a couple more fun structure examples. Choose meaningful axes. We have habits. If we're used to mapping and we're used to all kinds of geodata, that as soon as you get geographical data, you put it on a map. Well, sometimes that's the right answer. We have habits of, if you have time data, you should always use a time scale because, well, that's where it is. Well, that's fine. That can be useful. What do you do when you have time data and geodata? Like, then you're stuck, right? You put it on a map, you put it on a timeline. Well, the answer is you go back to your purpose and say, what are we actually trying to show? What is the relationship that matters here? And you use that to inform the structure. Notice I say use both axes, not all three. 3 dimensions is very hard to do successfully. I don't recommend it. There's a few cases where you can kind of get away with it, but generally it's very hard to do well. Typically, if you really need to show that much data, there's either other ways to encode it, or you can do multiple graphs that are similar enough that you can see the correlations among the graphs, but each one reveals very clearly the relationship pairwise between two axes. So let's look at some good structures. This is a map from the New York Times from 2010, a little line graph. So it's a change over time, but time is not one of the 2 primary axes. The 2 primary axes, the vertical axis is the price of gasoline, and the horizontal axis is per capita miles driven. So time, you will notice, is those little circles. Those are years. So time is included, but time is not the most important thing. The most important thing on this representation, on this visualization, is this correlation between how much does gas cost and how much do people drive. And there's some various, there's some various spikes, and there's some various other things that are affecting this. The Times did a slightly newer version of this in 2012, and I forget exactly what the axes were, but again, it was similar. It was things that are changing over time, but we don't need to make linear time constant. We can label time as this relationship goes back and forth between these axes. And so by really focusing on what is the purpose, by focusing on what the interesting relationships in the content are, we can choose a non-standard structure, non-standard axes, and get a much more interesting result. This is another fun one. This came out recently, and I'm going to zoom this in for a minute. I don't know if you guys can see that very well. What we have, that vertical axis, those are city names. So each row is a city, and then the columns are times. This is a graphical representation of flights, airline flights that are available. And so what happens is you take off, in this case from Seattle at the very top there, and time passes as you go to these other cities, and each of these are possible different stopover cities. And so these little shelves are when the airplane, when you're stopped over in a city, and then the slope goes vertical again as you take off and continue on your travel. This is actually a very new version of a very old format. This is often used, you'll see this with straight diagonal lines for train schedules, and this goes back to a French cartographer, 19th century French cartographer named Mary. So what this is showing is an axis of time versus possible geography rather than actual geography, because the endpoints are fixed, the city that you leave from and the city that you arrive at the end. But the stopovers, the stopover cities, these little shelves on the way, you're not stopping in each of them. No airplane stops at all of these. Or if you, wow, it'd be a really unpleasant ride if you stopped at 5 cities on the way. There's a lot of knowledge embedded here. The color, by the way, is just pricing. So in terms of the location, the time, the color is another axis. It's a third axis, the price. But so for the location and the time, you have this interesting thing where there's some subtle embedded knowledge here. The steepest slope is the nonstop, right? There's one nonstop flight, and that's the steepest because you're spending no extra time on the ground. This flight, the cheap one, this long green line that's got 2 stopovers, you're talking about the most elapsed time from left to right. Most time has gone by from when you depart to when you arrive. If you want to leave earlier in the day, you can look at the flights that are on the very left edge. If you want to leave later in the day, you can move to the right. And then these times, there's one other thing that they've done very nicely here. These times are consistent across the globe, but the digits are different depending on which city you're in. So the time scale doesn't vary, but it represents the change in time zone based on the city. And you've got light and dark depending on the day and the night. So you can see that you actually travel more than 24 hours. That longest green line is more than 24 hours long because you start in the dark, you pass through the light and through the dark, and you land again in the light. So very nice effect here. This is done this way because these are the things that are important when you're considering an international flight or even a domestic flight. What cities might I stop in? What time of day is it going to be when I land there? How much is the elapsed time? What time of day am I going to leave? What time of day am I going to arrive? Another example, by the way, that I really like a lot is Hipmunk. And that's a very cool other graphical display of flight options. This one you get a little bit more of sort of the visceral effect of where are you stopping. And what are the comparisons? So I probably would use Hipmunk actually to do my flight search, but I really enjoy the aesthetic of this display-wise. And again, bringing it back to the talk one more time, the structure. is revealing what's interesting here. And so this vertical axis is flexible and creative because not all of these cities are going to be on the itinerary, but they're all possible stops. And jumping back to the many eyes options, we talked before about the different relationship options, about the different ways that you might choose to represent your data. And then these are the plot styles that can reveal those particular relationship types. So if you want to track rise and falls over time in the center there, your options are going to be things like a line graph, a stack graph, or a stack graph for categories. Those structures are put under those headings because those are structures that are particularly well suited to reveal that kind of relationship. And so when I say that your structure is informed by your purpose, this is exactly what's going on here. You come to it with a purpose and you say, I want to see the parts of a whole. And this says, well, if that's what you're looking for, these are the structures that are going to best reveal the data that you've got. So intimately related, the structure that you choose absolutely depends on the purpose. Finally, formatting. A lot of people start the process of a graph or a visualization design with the structure and with the formatting. So when I say formatting, I mean labels, I mean which fonts you use, are you going to use highlighting, are you going to highlight with color, are you going to, what shape are the things going to be, and all that matters a lot. But very much like the paint on your house, if you haven't got a good foundation, what color the paint is just doesn't matter so much. So the things that are going to inform the formatting, well, you've got questions like, how does it look and feel? How will it be consumed? And of course, the mantra here, it's going to be informed by your purpose, by your content, and by the underlying structure. So this formatting, in addition to making the data and the relationships accessible, you want to see what's there, it's going to make what's important most visible. The formatting is really important for highlighting when there's a subset or particular pieces of the big picture that you want to look at. So just like I had the red circle around the dot that was the house that I grew up in, that calls that out, that highlights something that was important. Here's another example. This is a map from the LA Times. How fast is the fire department responding? And so I've clicked on one little hex there. There's that blue dot sort of in the bottom center. And so what we're looking at, just to the left at the bottom there, is the total number of responses, 1,300 responses, mostly medical, a few fire, and the average response time, 7 minutes. Now, the national standard is 6 minutes, and so anything that's under 6 minutes on this map is in green. Any of those little neighborhoods, those little hexes are in green. And anything that's over 6 minutes is in red, pink. And they've used a really nice encoding here with the saturation that the more something is, whether it's good or bad, the more of it is, the more saturated it is. So the best ones are the most darkest green saturation, of which there's very few on this map, actually. Almost nobody's got a response time less than 4 minutes. And the worst ones are much darker pink. That indicates you're going to be in trouble if you call 911 and you're in one of those areas. So they've done a really nice job. They've got this fundamental map, and they've done a really nice job with the encoding here with the pink and the green. And this is to show, is it above or is it below the standard response time? I'm going to change this just a little bit. And this is, if I was on the website here, I would click in that upper left corner. You see it says by grid, overall times. We're going to select the overall volume button, and we get this map. It's the same map. Nothing's moved. But now instead of that encoding of is the response time good, is the response time bad, we have an encoding of how many responses do we get. So I want to call your attention to two things. I want to call your attention, first of all, to the south there. A lot of responses, right? Lots and lots. It's very dark. And there's that sort of wedge area in the middle where there's very, very few responses. Okay? So what this is doing now with intensity here is it's showing us where this matters, where most of the people are going to be. And so keep in mind that there's the dark, the lots of responses at the bottom, and that empty gap in the middle there. When we go back to the response times, you can see that those really high response times, well, they get very few calls in those neighborhoods. Presumably, there's not very many people that live there. It's farther away. It's harder to get to. So maybe that's not such a dire situation, right? Whereas in that south center area where there was so many responses, it's actually fairly good. It's a very pale pink and getting into the green. So the map hasn't changed. The structure has not changed here. The underlying data with which they drew the map, you could argue, switches from one to the other. But what we've done is they've used this formatting, in this case this color encoding, but there's different ways. They've used this color encoding to highlight, to reveal some of these interesting relationships that are in the data underneath it. This is fun. This is fun to go play with. And you'll notice, by the way, one other nice effect that they've done here. On the left column, down below at the very bottom, when I'm looking at response times here, I'm sorry, when I'm looking at response density, they've highlighted in blue with the little red edge the number of medical versus fire responses. And we're looking at that same hex over here. The data is the same, right? You get the consistent view of the data in terms of both response time and the breakdown of the different responses, regardless of which map view you're looking at. So that you can see the data either way, and then the map view just lets you highlight the one versus the other. So that's using formatting to reveal something interesting. Okay, we're going to be on this slide for a few minutes. This is a table. I'm not the first person to create a table like this, but there's many versions of it. This one's mine. I'm going to blow it up to see it. This is a table that helps you understand which visual property to use to encode which type of data. You can download this, by the way, on my blog, complexdiagrams.com, the URL at the bottom, /properties, and you can get a PDF of this. Oops. There's the zoom. Okay. The way that this works is different visual properties like length, like angle and shading, density, they're interpreted by our brains in different ways. Some of these properties we consider to be ordered. Darker is going to be different than lighter, and we can say this is medium. Darker is on one side, lighter is on the other side. We can say, to some degree, this is a bigger angle and that's a smaller angle, although we're not very good at distinguishing subtle differences in angle. We're really good at distinguishing subtle differences in things like length and position. So if you look on the left, you can see what the properties are, a little example, and the name of the properties. Through the middle, there's these two columns in gray, whether they're ordered and how many useful values there are. And the reason that we have those two, why they're ordered, whether we perceive them as ordered, and this is perceive them as ordered, not whether they are ordered. That's a subtle difference we'll talk about in a second. Whether we perceive them as ordered and how many useful values there are, that's going to tell us which data types these are going to be able to encode most compatibly in the brain. So I'm going to call out just a couple of these because it makes a difference. The first row there, position and placement, naturally ordered. We all know which one's further to the side and which one's not. And there's a very large number, effectively an infinite number of useful values. It just depends on how big your screen is and what the resolution is. But you know, if you've ever built a web page or a photo display or something, and somebody comes along and says, that photo is 1 pixel too far to the left, right? We have really good resolution. People are really good at saying, that one's out of line. That one's a tiny bit bigger than the other one. So there's a large number of values, and we can tell they're ordered. I'm just going to cherry pick down the list just a little bit. For things like pattern density, it is ordered. We can say, well, that one is darker than the other one, but there's not really a large number of useful differences. You can generate with a computer a huge number of differences, but if you remember like old school newspaper, you know, a map in a newspaper, and this is the dark and the medium and the light, there's not very many really useful differences where you can say, oh, that's number 7 out of 15, and that's number 9 out of 15. You can't see those differences. They may exist, but they're very hard for us to perceive. The other really tricky one on here that I'm going to talk about for a minute is color. Now, you'll notice that it says color is not ordered. I have a physics degree. I understand that there's a spectrum and you can measure it. But your brain does not think about the world in that way. Your brain does not say purple is better than yellow or green comes before blue. You cannot depend on that. So color is fantastic for categories, for differentiating things that are equivalent, but it's really poor for rankings. It's really poor to say this one is better than that one or more than that one or bigger than that one. And you can use things like, so when I say color in this context, I mean hue. I mean changing from red to green to blue. You can use brightness or you can use saturation, like that map in Los Angeles did for more or less green, more or less pink, but that's all within one hue. Color is great for categories. Please do not use it for ranking by cycling through the rainbow spectrum. And if you've ever seen me speak before, I have a bunch of examples of this that I got tired of using, so you guys don't get to see those, sorry. So you take these properties, the visual properties here, shape, size, line encoding, et cetera, and they have whether or not they're ordered and how many useful values there are. And then the right half of this table shows you which data types then these are most compatible with and what the best data types to encode are. So if I have, for example, categorical data, I would look over in that right half to the categorical column and skim down that column, and everywhere it says good, that's a visual property that's going to be useful for encoding data that's categorical. So this is how the table works. Like I said, there's a PDF at complexdiagrams.com/properties. You can download the PDF of this and print it out. At some point, hopefully in the next month or so, I'll be updating the format of this, but the content will not change. So totally recommend getting this and thinking about this and using this as you are labeling things, as you're highlighting things, as you're choosing to encode the other data types that have not already been revealed by the axes that you've chosen, by the structures that you've chosen. I don't know, we're going to wrap up a little bit earlier than I thought. So here's the checklist, both as a designer and as a consumer of data visualizations. When you're looking at this, is this visualization that I'm creating or that I'm consuming, is it well defined? Is the purpose well defined? Do I know why it was built, or do I know why I'm building it? Does the content selected actually support this purpose? Does it tell me what I need to know? Does it tell me way too much? Does it tell me more than I need to know? If you have too much content, get rid of it. Do your audience a favor by doing that first filter stage ahead of time for them. Does the structure reveal the content? Does it reveal the relationships that matter? Does it show me what I care about? Is it a timeline when I actually wanted to see it on a map? Is it a map when I wanted to see it on a timeline? Is time woven through, like in the New York Times gas price versus miles driven graph? That might be the best way to do it. So does the structure actually the right structure for this? Have I chosen the structure appropriately? And finally, does the formatting facilitate the consumption? Have I highlighted the things that matter? Have I chosen visual properties that are compatible in the brain with the data types that we have? These are the interesting questions. Hopefully, as you design, just being prompted by these questions will help you make more informed choices in your design process. So that's my goal. And I did end up faster than I thought. Not quite ready for questions yet. I just want to say thank you. Before I get off stage, I'm having office hours in the expo hall at 1:30. So if you have questions, if you have graph styles that you're curious about how to implement, or you have some data that you don't know what the right format is or something like that, come ask me. That's a lot of fun for me. And I'll be at the IBM booth before that and after that. And then at 3 o'clock, signing and giving away books with Julie at the O'Reilly booth. So, there's usually a line for that, so if you want to make sure you get one of our books for free, I recommend getting there early. And that is the end of my talk. And now we'll go to questions. Very enthusiastic. Go ahead.
Going back to the Los Angeles visualization, you're clicking back and forth there, and I know you said don't use 3 dimensions, but what about time? What about a slider? What about animation? Go ahead and click back and forth on the overall volume. What about that? Do you have any comments on that?
Sure. Animation is really good for some things. Oh, sorry, repeating the question. The question is, what about animation? What about showing changes over time, that kind of thing? Well, the way you get back and forth between these two views in this case is you click back and forth, right? Here's what happens with animation. It's really cool to see some things, and it's cool to see some things evolve over time, but it makes it very difficult to compare earlier and later in time. So if you want to look at the price of something over time, you can watch it animate up and down, and that's good. But if you want to look at the later and the earlier price, it makes it hard to compare when it's in a movie. In this case, going back and forth, yeah, I mean, there's all kinds of things you could do, right? You could do a third representation that shows where is the best and worst intersection of density and response time, for example, right? Because we may not care that the response time is really bad through the middle there if they're only getting 3 calls a year, for example. I mean, one of those 3 people might care, but if we don't live there, we may not care so much. So, question in the front.
Could you advise tools for non-designers to create this kind of visualization? Perhaps also new tools coming up?
Advice on tools for non-designers to create visualizations. That's a really good question. Excel is not a bad tool. You can do good things with Excel. All of the defaults are wrong. And Every time I say that, because you all know what I'm talking about, right? The colors are terrible, the fonts are terrible, the axes and the grid lines are terrible, but you can do really good work with Excel if you change all of that. There's a woman named Cole Nussbaumer who blogs about Excel, and she will publish templates of really nice Excel templates so that those are all fixed. IBM's Many Eyes website has not been updated in a while, but we're actually going to do a relaunch of it in mid-March. And it's got some really nice layouts, as you saw. There's about a dozen different formats there. If you want to go more technical, there are more software, either visualization packages or full-on software tools. But for people who are not technical, not software developers, I recommend starting with the commonly available tools, probably tools you're already familiar with, and just applying good practice to those tools. Because you can do, like I said, you can do pretty good work in most tools. Not every tool is going to allow you every graph type, but you can do pretty good work if you bring the right purpose to it, you bring the right content, and you format it nicely. And the structure, of course. In here, in the back.
I'm probably not the only person who has gotten the feedback that a chart is too busy for executives to understand.
Yes.
Sometimes when you're trying to recreate a change in distribution of the data, and it goes off to one.
Yeah.
Any thoughts or recommendations on how to effectively communicate that without dumbing it down or figuring out the purpose of the distribution?
Yeah. So the question is, he's often gotten feedback that charts are too busy for executives to understand, a common problem. So how do you make the data, how do you retain the integrity and the resolution to some degree of the data without dumbing it down, but also making it simpler? I would say there's two approaches to this. One approach is you might simply reduce the level of labeling, right? So that instead of labeling every data point, you might call out just a few of the highlight data points and remove as much other labeling as you can from it. And the other thing that you can do is you can abstract a little bit. So you can aggregate data into domains or into clumps a little bit so that instead of showing 10 million data points, you're showing 10 regions, right? And this is the average for each region. And it may be, you say without losing purpose, if the purpose is to show it to an executive, that may be enough resolution for them to get the idea of the broad trend. And you may not need the individual, the highest resolution possible that someone who's really curious about individual events may care about. So I would say go back to the consideration of your audience and what they need to learn from it and use that to abstract a little bit and reduce your resolution so that they're not overwhelmed by detail that they can't act on. In the front?
Yeah, for some common charting paradigms, like the two-axis plot that you have for the oil,
Yeah.
prices and distance, people have come to expect certain things. So in this case, because the order by year,
Yes.
it's not really a function. So I could mistakenly assume that there is a correlation between the two axes, but it's false. So do you feel the need to explain when you use a common paradigm when you change it?
Yeah, really good question. If you're using something, the question is, if you're using something like a standard two-axis paradigm, but you're changing it up, right? This is a non-standard relationship. Do you need to explain when you're doing something non-standard? I think you do. In this case, there are labels on there. This was also part of an article that had a whole conversation about what was going on in this graph. So I think if you just put this in front of people and you did not, if you had just had standard, very subtle axes labels, it would be confusing because you're not doing the standard thing. And so when you're departing from what people expect, yes, you have to make special attention, say, I'm doing something different here, let me explain it, and reveal the value there. Good question, thank you. Oh, are you coming to shush me off or should we ask more questions?
I think you could take one more now and then we'll have to move it.
Okay, we'll do one more here and then we'll go to office hours.
For executive decks, you find that I ended up using a combination of charts, tables, and some bulleted text.
Yes.
Do you have any recommendations around what ratio to blend them in these things? Eventually it's about getting the message across.
Yes, interesting question. He said for presentations to executives, he often uses a combination of some charts, some tables, some bullet points with a highlight, and what's the best way to ultimately get the message across? Is there a recommendation for the ratio? I think you got it spot on when you said, what's the best way to get the message across? It depends on the message, right? And so it might be that you say, here's a graph, and we're going to support it with the 2 bullet points that say, this is what's interesting and this is what's important in this graph. This is the takeaway messages. So you can certainly tell people what you are also showing them. I would say tables of numbers are going to get you better resolution when the details matter. Graphs and visual representations are going to be better to show trends than a table of numbers. So if the trends matter, do it with a graph. If the precision matters, do it with a table. If you kind of need both, put both on there and call out, just like you said, call out with bullet points what the actual takeaway is, what the message is. Yeah. So I'm going to relinquish the mic. Come find me, like I said, at office hours or at the IBM booth this afternoon.